Another example, t x0, x1, x2, dot, 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 equals 0, x0, x1, x2, dot, dot, dot. And space for the transformation, this is actually mapping from U to U, where U is the space of infinite sequences. I would like to mention that none of our examples are just random things here. This has actually some applications. So what happens is that you have an infinite sequence of numbers, x0, x1, x2, and then it's shifted to the right. So this is actually called the right shift transformation, and it has actually important engineering applications. So now our U vector, if you want to show linearity, could be, for example, denoted by then U0, U1, U2. And then if you have a V vector in this space, then maybe an appropriate notation would be V0, V1, V2. It's not that different from the Euclidean vector space, but it does have infinitely many entries instead of a finite number of entries in the vector. Then the scalars, well, how do you want to multiply a vector? As I mentioned earlier, we mostly use the real numbers. So the scalar field is the real numbers. Then how do you multiply sequence? Well, how would you multiply if it wasn't infinite? If it was finite, then it would be a so-called vector, and you would multiply it entry by entry. So we do the same thing with the infinite sequence. We multiply it entry by entry. And then for linearity, to show it in one step with Cu plus dv, first of all, we have to write down what this Cu plus dv is. I already wrote down what Cu is here. So that would be term by term or entry by entry multiplication. Then we have dv vector. That will be similar. dv0, dv1, dv2, dot, dot, dot. Then we add also together infinite sequences, entry by entry. So we get Cu0 plus dv0, Cu1 plus dv1, Cu2 plus dv2, dot, dot, dot. And then, so we have a parenthesis for the transformation and another parenthesis, a set of parentheses for the vector. So this right shift, what it does is it zeroes out the first entry after shifting it to the right. The order, of course, is important, that first shift it to the right. So we start in the second entry with Cu0 plus dv0, Cu1 plus dv1, Cu2 plus dv2. All right, so then what do we do? Well, I think it's hard in this case to go backward and get immediately that this is C times Tu plus D times Tv. I think it's better, it's complicated enough that it's better to start with the right-hand side and calculate it and then compare the two together. So we have what effect of T is on U, 0, U0, U1, U2. Then D times the effect of T on V, V0, V1, V2. Then we add together. Well, first of all, we multiply through, and then we add together. But we can do it really in one step. So C times U0, that's the second entry, plus D times V0. Then C times U1 plus D times V1, dot, dot, dot. And then we see that these two are the same, which means that this property 3 is satisfied, and that means that T is linear. It's interesting to note that if you change the 0 to some other number, then you might get a nonlinear transformation if you work it out, but you do have to work it out. Some of these homework assignments are not trivial at all. You have to show the linearity step by step.